Welcome to Introduction to Macroeconomics. And we're going to look at the big picture right now before getting into some details. We're going to be talking about what is macroeconomics, how does macroeconomics study key questions, and long run versus short run. Macroeconomics is the study of general features of the economy and how interactions by agents affect overall economic activity. An agent here could be a person, a household, a firm, or any other independent decision-making economic agent. In short, we're looking at the big picture. Macroeconomics as a separate discipline within economics is less than 100 years old. Microeconomics, on the other hand, is around 200 years old. So macroeconomics is the junior partner compared to microeconomics. So if you ever get the sense that macroeconomics is not as developed or advanced or certain as microeconomics, there's a good reason for it. Microeconomics had a 100-year head start. Another issue with macroeconomics is that macroeconomics is more political than microeconomics. During general elections, there is ferocious debate about growth, about unemployment, about global issues, whereas microeconomics tends to focus on specific industries and specific industry technical questions. So microeconomists are not on the radar nearly as much as macroeconomists. So when you hear people disparage economics because of political and economic policy disputes, inevitably they're pointing to macroeconomics as the culprit. When you get into microeconomics, you have a lot more certainty and consensus and kind of scientific strength, if you like. The good thing about macroeconomics, even though it's not as old as microeconomics and even though it doesn't seem as certain in its conclusions, it certainly does relate to what you hear about in media, in the news, and in the debates that get people worked up. Okay, so what actually do macroeconomists study? They study long-run growth, that is growth over many years, the move from poverty to wealth of nations. They study inflation, and they study the business cycle. The business cycle is booms, busts, recessions, and periods of prosperity. So 1, 2, 3, long-run growth, inflation, the business cycle. This is what we're going to be talking about. And this is the organization of the typical modern macroeconomic textbook. The emphasis in macroeconomic textbooks has moved toward putting long-run growth as the first topic, with inflation and business cycles following. I should also say that business cycle theory is the most contentious and least well known, so it only makes sense that we should leave that to the end. Now, here's something you probably haven't heard before. If you look at those three topics, 1, 2, 3, notice something? They all involve time. The concept of time is central to macroeconomics in a fundamental way that's not really true of microeconomics. Microeconomics does have problems and models with time, but time is fundamental to all problems within macroeconomics. We're talking about the present and the future. We're talking about change, in some cases, over generations. Okay, so what? So why does that matter in a practical way? Well, one way it matters is that since macroeconomics deals with economic values over time, macroeconomics has to allow for inflation in all of its calculations. In all of the data, we're going to have to allow for the fact that typically a dollar in the future is worth less than a dollar today. Those of you who've studied intermediate microeconomics or even principles of microeconomics typically don't worry about inflation. A dollar is a dollar. A dollar has a certain value in most problems, and you don't worry about declining values. In macroeconomics, everything we do, we have to build in a correction or an adjustment for inflation. So, as I hope you remember, inflation deals with the change in the general level of prices. When the price of everything has increased by 10%, that means that $1 has lost 10% of its real purchasing power. Long-run growth deals with general changes in the general standard of living of the general population over time. The business cycle is a fundamentally short-run question of deviations over time from the long-run trend in production, consumption, and employment. So the short-run issue of the business cycle is benchmarked against the long-run trend growth rate. In this little diagram here, you see a blue line, mostly straight, showing long-run growth according to traditional long-run growth trends in the United States. This is a United States diagram. The wavy red line is tracking the change in GDP, that's gross domestic product, total production. The red line is tracking GDP for its actual value between 2005 and 2014. The fall in the red line below the blue line between 2007 and 2009 represents that short-run Great Recession effect. The return of real GDP towards something like a long-run traditional rate of growth, that's the long-run effect, the long-run real growth rate aspect or dimension of the economy. So, in summary, this graph is capturing both long-run behavior and short-run behavior. In this course, we're going to be talking about the behavior of the blue line first, the long-run behavior, long-run growth issues, and the final section of the course will be dealing with that wacky red line behavior when it fell away from the long-run trend. Now let's get a little bit political about this diagram. The great thing about macroeconomics is it does relate to political things. Consider that red line is not catching up to the blue line. In other words, it appears as if the economy has suffered a one-time fall in the amount of real GDP per capita, and that loss is not going away. So look at the far right of both lines. there's a gap there of about $800. So it appears going into the future that every person in the United States, on average, has lost $800 per year of GDP indefinitely into the future. So that's not a very satisfactory outcome, and it does explain, without invoking anything to do with inequality, by the way, it does explain why right now there's significant amount of dissatisfaction, let's say, with the economic state of affairs. Remember, this is not a one-time loss of $800 per head. It appears that each subsequent year, that $800 income loss is occurring again and again, compared to where we would have been if there were no Great Recession, if we had stayed on the blue line. So, and we don't need to invoke inequality issues even to get to that. So, we'll talk more about this business cycle stuff later in the course, but it is very pragmatic and it affects how people are living their lives every day. Now we'll talk about a little bit about methodology. The standard characterization of macroeconomics is that macroeconomists use a combination of facts, models, and predictions to analyze the economy, and they test theories, they test the hypotheses, and if the hypotheses are not validated, they revise their models and theories and try something else. Now, the actual story is a little bit more complicated. The good news is we do have a lot of macroeconomic facts. We do have a lot of data. In fact, if you include financial data, there's a tsunami of new data every day generated by financial markets. So there's plenty of numbers that macroeconomists have available. But the very abundance of data means that you need some kind of scheme or model to figure out and extract the underlying things that we should care about. That's why economists, like it or not, and macroeconomists too, have to use models. Model is a story about the economy. Typically, these models are written in the form of equations. Now, when you use the word model and equations, some people get quite agitated about it. They say stuff like, well, you cannot use models like in science for economics. Economics is dealing with things beyond math or beyond, it's not science, in other words. Now, there are two responses to that kind of challenge. One response is, yes, it's true that sometimes economists get so enamored of the math that they forget about the human dimension. And so that's a legitimate caution, a legitimate thing to keep in mind. On the other hand, the objection to using math as such is not really valid, and the reason is this. A good model is a model where the math has a good interpretation in terms of the real world. The math is not the point in itself. The math is like a language, the math is a way to clarify ideas, the math is a tool and not an end in itself. Ideally, a good economic model is really a story about human behavior, how humans interact with each other, and how humans interact with the world. So think of the math not as a math problem to be solved. Think of the math in the models we'll look at as really just a language that is telling a plausible story. Now, what about predictions? Can economics ever make predictions that are testable, that we can actually check? Well, sometimes yes. And one good example is inflation. Inflation is a phenomenon that inevitably, when it's very high inflation, always relates to overproduction of money, printing too much money, that is, chasing too few goods. So in that case, we can actually make very good predictions about what to expect, what will happen, what the cause is. Now, there are other areas in macroeconomics where it is a lot harder to predict, and we'll try to discuss all of this kind of later. Now, experiments. There are three types of experiments in macroeconomics. One kind of experiment is called the natural experiment. A natural experiment is an experiment where the world has delivered us a test of a proposition, and what we're doing is looking at what happened in the world. The best example people use is North Korea and South Korea. Until recently, same country, same people, same history, same language, same everything, and then because of war in the 1950s, the two countries were cut in half. North Korea followed a very different path from South Korea, and after many years, we can look at the different results. It's like a natural experiment. In the case of Korea, we are controlling for the things that typically confuse the question of long-run growth. We don't have to worry about history, about language, about ethnicity, about culture. It was all the same. And the only thing that really changed was the political rules, the political institutions. And that's a natural experiment. Now, another kind of experiment macroeconomists do is run simulations. They have some models with a lot of math. They plug in plausible starting point numbers. They run the model through various iterations, and they come out with outcomes. It's a curiosity of macroeconomists that they use the word experiment for what everyone else would call a simulation. So that's the second kind of experiment. And the third kind of experiment is the kind of experimental economics experiment, or some of you are familiar with behavioral economics. They're really very similar things. Experimental economists and behavioral economists create artificial situations and test various hypotheses and look at the results. And some of those experiments can be done in macroeconomics, and some of those experiments are very enlightening and useful. The experiments which are useful are the ones that get into basic human behavior. And when we talk about asset markets like the stock market, there are certain fundamental psychological biases that people have, even experienced traders have, and you can capture some of that stuff in a controlled experiment. So that's the third experiment. Three types of experiments: natural experiment, the simulation experiment, and the laboratory or field experimental economics type experiment. Those are the three. Now, exogenous variables in a model are the variables that are just where the values are given to you without explanation. It doesn't come from the model. We just assume a variable has a particular value. Endogenous variables are variables whose values are determined from within the model. When you set everything up, you put in the values for the exogenous variables, you solve the model, the answers you get are the endogenous variable answers. And parameters are numbers or values that are given to you, to the model, and those parameters are assumed to be dictated by things outside human behavior. They're like given by technological forces or other aspects of the economy. The textbook talks about this. We'll talk about more about this in future. And I'm going to talk about an actual model in the next slide. So here I have for you the equations of the solo growth model, which is a model we will actually be studying later. And I will run through quickly what this math is saying. I'm going to interpret the math, the equations. I want to demonstrate to you that a model in economics written in math should be interpreted as a story, not just as a bunch of equations that need to be solved. So, the first equation for Y, the Y is total output in the economy. A is a technical parameter given by the productive conditions. K is the amount of capital, the produced means of production, like a factory. L is the amount of labor, the amount of workers, let's say, that are being used. So you take a factory, the amount of which is measured by K, you populate it with workers, the number of workers is given by L. The little alpha there is a positive number between 0 and 1, so the K has a positive effect on production. The L has a positive effect on production also. 1 minus alpha, let's say alpha is a half, 1 minus a half is a half. So you increase K, you get more Y. You increase L, you get more Y. How much Y do you get exactly? That's what the exact value for alpha and the exact value for A tell you. So that's like production from a factory. The I equation, I means investment, and in this economy, the total amount of investment depends on the amount of people save. S is the proportion of income that people in this economy save. Y is the total amount of income they have to spend. So depending on what S is and depending on what Y is, we get a certain amount of investment. That's like creating new factories or maintaining existing factories. We go down one step lower. That's an equation that tells us how much the total capital stock or number of factories will increase once we allow for the amount of saving, the amount of factories that we inherited from the previous period, the previous year. The T means a time period, like a year. And it also depends on this D thing, which I won't get into right now. Going down L, the amount of workers we have depends on the amount of workers we had in the previous time period plus population growth. So workers grew in numbers because the population grew, and N is the rate at which the population is growing in a sense. The final one, A. This A parameter is a parameter that depends on growth in the proportion of knowledge, basically. And I don't want to get into that very much. Suffice to say, A has its own rule of growth. So what I've just done is explain this solo growth model, which is just a bunch of equations in terms of a story. You get more capital, you get more workers, you get more output. The amount of capital that you have to work with depends on things like how much people save. It depends on how much capital you brought over from the previous period. And it also depends on how rapidly capital depreciates. That's what the D thing is about. The number of workers depends on population growth. And this A thing is a sort of a multiplier of productivity that itself can grow and improve over time, and you could interpret that as technological progress. So throughout this course, whenever we come to a model like this, written in equations, it is very important you get the intuition. This course will be very much focused on intuition, not just looking at equations as equations. Okay? It will be much less painful to understand a model if you think of it as a story and the math is just the language that is telling the story. Okay? Finally, my final slides are to do with the facts question. And next time we're going to be talking about some basic macroeconomic facts, because we have to be working from a common base of knowledge about how the world has worked over the last few years or even centuries. The person on the left is Angus Deaton. He was the 2015 Nobel Memorial Prize in Economic Sciences winner. He was the sole winner. He didn't share it with anybody else. His specialty over his entire career was collecting facts about economic growth and health in all the countries in the world. So he is a data guru or data expert, and he spent his entire life gathering, analyzing, compiling data. So he is the preeminent economic historian with respect to economic growth. Now on the right side, you see the type of data that you come out of the work of Angus Deaton and people like himself. The diagram on the right shows that since 1981, the prevalence of poverty in what we call developing countries has decreased remarkably. In 1981, 71.5% of the people were at about $3.10 per day in adjusted dollars. The dollars here are corrected for inflation, by the way. So 1981, over 70% developing country people had about $3.10 a day, okay, or less, I should say. They had $3.10 or less. The orange line there tells you the proportion of people in developing countries at $1.90 a day or less. Now compare that with 2012. What you've seen is more than 50% fall in global poverty among the poorest people in the world. Let's be clear. Since 1981, the number of desperately poor people in the world has decreased remarkably. So the worst off people in the world are better off today than they were in 1981. Now, there's a lot to talk about why that happened. But let's be clear, the world is not getting poorer, especially if you look at the poorest people in the world. The poorest people in the world have benefited tremendously from things like trade and things like technology. Okay, so we will discuss some of these facts next time. See you later.